1 minute. Okay, I hope it's visible.
It is.
Okay.
I'm gonna say, sorry, funny, not funny. Like I use Notebook LM for mine, and you use Claude for
Really?
yours. I
Yeah.
can tell now. I love it. All
Oh,
right, it's
yeah.
all yours. Thank
Thank you. Okay, thank you so much. Okay, hey everyone, welcome and thank you so much for joining session two of our DP-800 series. My name is Mithuna Mohanraj and I am a Gold Microsoft Student Ambassador. So today's session is the second of the three that together form the complete exam preparation for this DP-800 series. So here we'll just go deep into domain two, which is securing, optimizing, and deploying database solutions. So this makes up 35 to 40% of your exam score. So if you get through these two sessions today, make sure it's one of them. And we have 45 minutes together, so let's move efficiently. I'll pause briefly in between for questions, or we'll just have a dedicated Q&A after the session's completed. So without further ado, let's get started. Okay, so here's what we're going to cover today. There are five major stops. The first is data security and compliance, which is about 10 minutes covering all the mechanisms like SQL servers, uses to protect your data from unauthorized access and all that. The second would be performance tuning. And then the third would be the CI/CD for database, which is another 10 minutes of your database schema, like code where you treat it and then you deploy the pipelines and all of that. The fourth one would be change tracking patterns, which is going to be another 10 minutes on how your SQL Server captures data. And finally, 5 minutes for exam tips and your questions. So keep your Microsoft DB800 study guide open if you want, and I'll reference specific topics you want to review in depth after today. So let's get started. Sorry, I just have to keep admitting people in between. Okay, so before we dive in, I want to make sure that the weight of this domain lands with you because 30 to 40% is a lot, and that's single largest domain in the entire exam. So, security questions appear in every exam version. They're not optimal or optional content, but performance tuning is always presented as a scenario. So, a user reports slow query performance after a routine update. So, which action should you take? Something like that. So, the CI/CD knowledge is where many early career professionals have gaps. And the exam tests whether you understand the modern database DevOps workflow, not just like writing SQL. And change tracking is the bridge to domain three. How your data changes, how you deal with them, how the flow goes on. So if you master this, you've got a real shot at passing. So I really hope this works out for all of you. So let's kick off session one, which is data security and compliance. So, as we know, the Microsoft SQL ecosystem gives multiple layers of protection. The key is knowing which layer solves which problem because the DP800 exam will absolutely test this distinction. So, here we're going to cover four major mechanisms, which is always encrypted, dynamic data masking, role level security, and manage identity authentication. So let's start with the most powerful one, which is always encrypted. So, always encrypted is Microsoft's answer to a specific and serious threat. What happens when a privileged insider, which is a DBA or maybe a sysadmin, a cloud operator, tries to view sensitive data they shouldn't see? So, traditional encryption protects data on disk and in transit, but the moment SQL Server loads the data to process a query, it's decrypted in memory, and a sufficiently privileged user can actually read it. So always encrypted changes this entirely. So the core concept here is that with always encrypted, the encryption and decryption happen exclusively on the client side, meaning that in the application, The SQL server never sees the plain text. Even when running a select statement, the server returns ciphertext. So only the application which has access to the column master key can decrypt it. So think of it this way. Imagine there's a bank vault where bank manager can move boxes but cannot open them. So SQL Server is that bank manager. The application is the only one with the combination. So your data is secured and hopefully no one can see it. So there are two key types here specifically, which is the column master key and the column encryption key. So this lives outside the SQL Server in the Azure Key Vault, Windows Certificate Store, or another key provider. So it's the root of trust. So the column encryption key or the CEK is actually what happens or is what actually encrypts the individual column values. So this CEK itself is stored encrypted and the CMK decrypts the CEK. So this is the key hierarchy. It's also important for the exam. So just remember that the CMK decrypts the CEK. And then we also have types of encryption, which would be deterministic and randomized encryption. So you will need to choose an encryption type for each column. Deterministic always protects the same ciphertext for the same plain text. So this means you can do equality comparisons and joins on the encrypted columns. It's very useful for things like social security numbers, like your important IDs or any number that you want to keep safe, where you need to look up by exact match. Whereas randomized is it provides a ciphertext each time. So even for the same value, this is not secure. And you cannot query or join on whose columns. So we use this for like full credit card numbers, medical records, or where you only need to retrieve the value, not the filter. So one exam tip that I would like to add on here is if the scenario asks about protecting data from the DBA and still being able to query it by the exact match, then that would be deterministic. Whereas if they ask for maximum security with no querying needed, that would be randomized. So just keep this in mind and it should be good to go. The next one we'll be talking about is dynamic data masking and row level security. So, dynamic data masking is a different kind of protection. It doesn't encrypt the underlying data at all. So, instead of um, what users see in the query results is based on their permission. So it depends on what you permit the person to see. So let's consider a real world scenario. There's a customer service agent at a telecom company who needs to look up accounts. So they should be able to find the account by phone number, but they couldn't see the full credit card information. So with the DDM, the billing column shows um, something like you can see here XXX and then only the last four numbers for the credit card up to the agent. So the billing system service account, which has the unmasked permission, sees the full number. So this is configured at column level using mask functions. The default function masks everything. So email just shows the first letter and the domain. It lets you define how many characters to show from the start to the end. And random, you see here, is a random number within the range. It's very useful for testing data scenarios. So the critical limitation here is that DDM is not a security boundary against users with select privileges or unmasked permission. It's more like an obfuscation of users who legitimately access the table but shouldn't see sensitive details. So just don't confuse them with encryption. And then we have row level security, which is this solves a different problem actually, not what columns a user sees, but which rows. So it's perfect for multi tenant architectures where multiple customers share the same table. So just imagine your SaaS application. There's company A and company B, both store their orders in the same order table, maybe because that simplifies your schema or reduces costs. So without the RLS, a bug in your application could accidentally show company A's orders to company B, which means the database itself enforces an isolation no matter who accesses it. matter what the application does. So the RLS works through security predicates. There is this filter which silently filters rows from the select, update, and delete. And there is a block predicate which prevents writing rows or ones that don't match the predicate. So you implement them as an inline function and it just goes on. So one key exam distinction I would say is RLS is transparent to the application. The app doesn't need where clauses. And this is both the feature and the potential thing for developers to realize rows are being hidden. So just remember that DDM is not equal to security from privileged users, whereas RLS is transparent and both can be combined. One more thing, our next topic is managed identities or password authentication. So the golden rule here is that applications should never store database passwords in config files or code. So let's just talk about authentication. So specifically how modern Azure applications should connect to the SQL database without passwords. So the traditional pattern was usually storing a connection string with a username and password in an app configuration file or environment variable. So this is a very problematic because secrets in the config file get committed to the source control, shared with developers who shouldn't have them, forgotten and never rotated, and exposed in logs. So the system assisted managed identity, Azure solves this with the managed identity. So a system assisted managed identity is automatically created for Azure resource. Say your app is service or Azure function and it's tied to like a one-on-one resource. So when the resource is deleted, the identity gets deleted. So you grant this identity permissions on Azure SQL and your app authenticates using the managed identity token. So you do not have any passwords in the connection string at all. So one real-time example would be your app service connection string looks like, let's say there's a server equal your database, and then authentication would be the active directory, which is a managed identity. So there's no username, no password. Azure handles the token exchange automatically. And then we have the user assisted managed identity, which is just a standalone resource. It's an Azure research you create separately and then assign to one or more resources. So it persists even when individual resources get deleted. I think someone has a question, but I think we can get back to it. I'll just finish this portion. So yeah, talking about the user assisted managed identity, this is a standalone resource, which is something that you create separately and assign on one of the resources. So it persists even when individual resources get deleted. So this is ideal in manufacturers where there are like 5 different function apps. Then all you need is the same access key to the key vault and the SQL. So you assign one identity to all of them instead of managing 5. So that's the main function of this. And then we have the eVault, which is the passwordless authentication patterns. This is mainly for remaining or maintaining all the secrets. So even with managed identity, you might have some secrets that cannot be avoided, like third-party API keys or legacy system passwords. So these go into the Azure Key Vault. So your managed identity gets the get permission on the key vault. So your application retrieves all the secrets at runtime without storing them anywhere. So they might ask you to choose between the connection patterns. So managed identity is always preferred as a native answer because connection strings with password in the Azure app never, in the Azure settings specifically, is acceptable if the key vault is also in the secret storage. But passwords in the source code or config file is never correct. So you cannot always trust them. Then we have, okay, performance tuning. Before that, we've just covered the security layer of the SQL ecosystem. So let's shift to performance. performance now that we're done with the security portion. Because performance tuning on the DP-800 is about diagnosis and prescription. And the exam gives you a scenario, a query, and then it asks you what you do. So this is more of a scenario-based situation. So the tools we're covering in this session are your diagnostic toolkit. So let's get into it. So every SQL query you write gets translated into a physical execution plan by the query optimizer. So this plan is more like a step-by-step map of how exactly the SQL query retrieves your data, which index it uses, how it joins tables, how it sorts results. Learning to read it is arguably the most valuable SQL skill that you can develop. So let me start by teaching you how to read the plan. Because execution plans are read right to left and top to bottom. Remember that it's not how we usually do from left to right, but it's right to left and top to bottom. So each operator is shown as an icon, and the thickness of the arrow between the operators represent the estimated number of rows flowing through. So thick arrows on expensive operators are your first clue that something is definitely wrong. There are a lot of red flags actually, which can let you know about the high cost operators. The first one is a table scan, means that the SQL server is reading every single row in the table. Unless your table is tiny, this is super expensive, so try to avoid that. A clustered index scan is very similar, reading the whole table through the clustered index. And then, like I said, um, a key lookup is what happens when the SQL server uses non-clustered index to find a row, but then it has to go back to the clustered index to fetch additional columns, which is not in the index. So this is a common performance killer and often fixed by adding those columns as include columns to the non-clustered index. So an implicit conversion warning triangle. So sometimes you get that triangle, which means that the SQL server is converting one data type into another on the fly. So it's often preventing index use entirely, and this happens when your where clause uses a different type than the column, like comparing a varchar column to an integer. So what are the common fixes for all of these issues? So for missing index, remember that SQL Server always shows a green banner with a suggested index and an estimated percentage. So take these seriously, but don't blindly create every suggested index because indexes have write overhead. For parameter sniffing, the classic symptom is stored procedure that runs fast, sometimes slow, and it really depends. So the SQL Server cached a plan optimized for one parameter value, then reused it for a different value. What would be the fix? So your fix options would be option recompile on the query, option for hints, or the SP execute SQL properly. So one tip that I would like to add on here is the DP-800 presents execution plan screenshots in scenario questions. So you look for the table scan, which is the ones which are bad, and then the key lookup, which is fixable with include, and then any warning triangles you see, which is more like a type mismatch or a stacked issue, and the thick arrows on sort or hash operations, which is basically the memory pressure. So look out for all of these signs. It's pretty simple, but practice. So the more you look into it, the more you'll understand. And then we have query store and dynamic management views. So query store is one of the most powerful features in modern SQL Server. So think of it like a flight recorder for your queries. It continuously captures query text, execution plans, and runtime statistics, CPU time, elapsed time, or logical reads, memory grants, and stores all this history persistently in the database. So before Query Store even existed, if a query suddenly got slow after an upgrade or statistical upgrade, you would have no idea what the old plan looked like because it was not stored anywhere. So this is a common So with Query Store, you can pull up the regress queries report and see the exact plan, like which was used before and after the regression, compare their performance, and then force the old plan into a single click. So the database enforces this plan choice until you remove the override option. So in Azure SQL database, Query Store is always on. For the SQL Server, you can enable it with the alter database, I guess. There is this option called set query store equal on. When you turn that on, it works with the read write option. And you can also configure data retention, maximum storage, and statistical collection interval. So, one powerful extension is automatic tuning in Azure SQL. This is specifically the force last good plan feature. So, whenever Azure detects a query plan regression, it automatically forces the last good plan. So, this essentially automates what you do manually with the query store. This is very similar, but just like an automated process. And then we have the DMV, which is the dynamic management views. This is also called the real time server intelligence because when Query Store gives you historical data, DMV gives you real-time visibility on the SQL's internal state. So their system views, you query with regular select statements, no special permissions beyond your view server state, which is needed. And you see the sysdm execute request here. This shows you every query currently executing. So you can see which sessions are blocking others and what type they're stuck on and how they're running and all of those. Whereas the stats gives you, it just aggregates the runtime statistics across all executions of every query in the plan cache. So this is how you find all your worst time offenders. So query queries consuming the most CPU or the most memory, the most IO since the last server restart. Whereas the sysdm missing index basically gives you details of it exposes the same missing index hints which you see in the execution plans, but it's more like something which is aggregated across all the series system wide. So you can prioritize which indexes to create based on the total impact. Lastly, we have the wait session and the execution session. So the wait is incredibly valuable for bottleneck analysis. So it mainly categorizes exactly what SQL Server has been waiting for. Is it the disk I/O? Is it the lock? Or is it the CPU scheduling or memory grant? So the wait type distribution tells you where to focus on your tuning effect. So again, another exam tip that I would like to add here is that the DMVs require the view state permission. So in Azure database, some DMVs have scope limitations. So know which DMVs are for real-time analysis versus for historical cumulative stats, which is what we spoke about, the SysDM query stats. This is very similar to that. And then we have column store indexes and table partitioning. So traditional SQL Server indexes, let's say row store, B tree indexes, these are optimized for the OLTP workloads, which means fast lookup for individual rows. You don't have to go search everywhere. It's very easy to look up. They have frequent insert and updates. But analytical workloads do something very different. They read specific columns across millions of rows for aggregation. So column store indexes store data by column instead of row. So you have it in the name. Remember, column store stores by column and not by row. So when your query reads only 5 columns from a 50 column table, a column store reads only those 5 columns from the disk, which is like a 90% reduction. And on top of this, the SQL Server applies batch mode processing where operators process 900 rows at a time instead of one at a time, which is dramatically better CPU utilization. So, what is the impact like in real world if you think about it? Let's say I've seen sales reporting queries go from 4-minute runtime to under 10 seconds after adding a clustered column store index. So that's not an exaggeration, and this is genuinely transformative for the right workload. So these have two types. One is clustered, the other is non-clustered. So clustered column store replaces the entire B tree structure. So the table is the column store. It's very good for pure analytical tools like fact tables in a data warehouse, whereas non-clustered column store is added alongside an existing row table. So the application gets both fast OLTP operation and fast analytics. This is the best of both world pattern often used in operational analytics. In Microsoft Fabric and Azure Synapse, the column store is the default format for large tables. So the DP-800 exam will test this in the context of, sorry, let me just admit people. Yeah. So, like I said, in Microsoft Fabric and Azure Synapse, the column store is the default format for all large tables, and the exam will test you in the context of Fabric. So, know that Delta tables in Fabric use the Parquet format with similar column store storage principles. So, just make sure you know the differences so it's much more easier for you. So we spoke about column store. So what is this table partitioning? So table partitioning basically divides a large table into physically separate segments based on your key column. So almost always maybe a date or a date time column. So the query optimizer uses this partition elimination where your where clause includes a partition key filter. It reads only the relevant partitions and completely skips the rest. So this is critical for large historical tables. Let's say you have 5 years of transaction data partitioned by month. That's like 60, right? So a query for this month reads 1 by 60 of the data. For compliance purposes, you can switch partition to an archive table in milliseconds without touching the rest of your data. So this implementation involves a partition function that defines the boundary values, a partition scheme that maps partition to the file groups, and the table definition that references the scheme on the partition column. So, one exam tip here that I would like to add on is indexes appear in the DP-800 context for Microsoft Fabric and Azure SQL. So, know that clustered column store is best for analytical only tables, whereas non clustered works with mixed workloads. So, partitioning itself is about managing large tables efficiently. You can just understand it from the name for partitioning the tables. So, yeah, just remember that. Okay, then we move on to the CI/CD for database. So we went over security, we went over performance tuning. Now let's talk about something that trips up a lot of developers, which is treating database changes with the same rigor as application code changes. So in modern engineering teams, a developer doesn't just connect to a production database and run the alter table. That's the old way. So the new way is to have source control, automated deployment pipelines, and safe rollback strategies. And that's what this session is about. So let's get started. The first one would be the SQL database projects or schema drift management. So, a SQL database project is essentially your entire database schema stored as the SQL files in source control. So, every table view, stored procedure, function lives as a .sql file in your Git repository. So, the project builds to a DACPAC, which is basically a database application package, which is a deployment artifact like a Docker image or a jar file in your database. So the SDK style project is the modern format. It uses the same project file conversions as .NET SDK projects. It's a cross-platform, works in VS Code with a SQL database project extension and integrates naturally into GitHub Actions and Azure DevOps pipelines. So here's how the workflow looks like in practice. So let's say a developer needs to add a new column to the orders table. So instead of opening SSMS and running the alter table function, directly. They open the order.sql file, add the column definition, commit to Git, and then open a pull request and get the code. So the CI pipeline runs a build to validate the SQL compiles, runs any database unit, and on a merge, the CD pipeline deploys the DAC PAC into the target environment. So this gives full audit trails. You can exactly see when every schema change was made, who made the changes, why they made the changes, and enables rollback as well. So you can always revert back your commits. So you don't have to worry about it being permanent. Then we have yep. Then we have the secrets of management, which is okay. Here, one important thing to remember is that never commit database passwords or connection strings to Git because this is very risky because your data or your password might get stolen. So this is a very critical security failure question in exams. But remember, never put any information into Git. So there are actually four types. This mainly covers all the common topics and how you handle them in the CI/CD pipelines. So the worst thing you can do, like I said, is putting a database password in a pipeline file and commit it to the source control. I've seen this happen a lot at real companies because password ends up in the Git history forever. So when you think that, okay, let me just like delete it, like revert back, your history still remains. So your password is just going to be there. So it's visible for everyone in the repository to access, even if you delete the line later. So this exam will present scenarios where you need to choose the correct approach to the secret management. So let's go through the right answers. So we have four types. Let's start with Azure Key Vault. So Azure Key Vault is the canonical place to store your secrets in Azure ecosystem. It's a managed HSM based secret store with access policies, audit logging, and soft delete. So your CI/CD pipeline should have a managed identity that has a get permission on the secrets it needs from the Key Vault at the runtime, never storing it in the pipeline definition or logs. Whereas your GitHub Actions and Azure DevOps. So for any short-lived values that don't need to persist across environments, use your CI/CD platform's native secret store. So in GitHub Actions, secrets are configured in the repository settings and are referenced by using the DB password, this thing you see here in the YAML. So these secrets are masked in logs automatically. So it has this equivalent variable group with a lock, which is basically a secret option. And then we have the OIDC and Workload Identity Federation. So the gold standard is eliminating passwords from the pipeline entirely. Using OpenID Connect, GitHub Actions can authenticate to Azure and assume a managed identity without any stored secret. So if Azure issues a short-lived token for each workflow run, there's nothing to rotate, nothing to leak, nothing to store. So your data is all safe, and this is just like a one-time thing. So this is the architecture Microsoft recommends for all new pipelines. And then we have the parameterized connection or parameterized connection strings. So SQL projects support this SQL CMD variables, which is basically a placeholder token in your SQL files that get replaced with the actual values at deployment time. For example, your SQL file references, let's say your admin user, and your pipeline injects the actual value from the Key Vault. So this keeps environment specific values out of your source code entirely. So, another exam tip I wanted to add here is if the question asks where secrets should be stored in Azure Key Vault, then it asks how applications should access Key Vault, its managed identity. If it asks whether connection strings, sorry, connection strings with passwords in the app settings are acceptable, then yes, it's acceptable only as the last resort when Key Vault isn't used. So always remember Key Vault plus managed identity is always preferred. The rest of them come after that only if you do not have a choice. Okay. The last set of things we'll be covering quickly is the change tracking patterns. So we have three of those. Again, like I said, this session is also very important because in domain 2, it's more like a bridge between 2 and 3. So the ability to capture the data changes and feed them into AI pipeline is central to building the entire database applications. So let's quickly dive into these three distinct mechanisms. The first one is change tracking, which is more like a lightweight synchronization. This is the simplest mechanism. It enables, you can enable it on your database table, and the SQL Server tracks which rows have changes, since the synchronized version is a monotonously increasing number. So you can ask like what changed since version 1000 or version 100, and then you can use the change table function, and it gets back the list of primary keys that were inserted, updated, or deleted. So what you do not get is the old values or the new values of the change columns. So you only get the primary keys so you can compare and figure out what changes were made. Whereas for the change data capture, this is more like a full audit trail. So this is significantly more powerful and more resource intensive because it reads all the transaction logs asynchronously and writes full before and after images of every change row into your system, and it calls the change table. So you get the row that was before, the row that is after the change, and the type of operation. Like you can exactly see what operation was made: insert, update, delete, whatever. And with the timestamp, which is really good. And then the last one is change event streaming, which is the newest of all the three, and it's the most event driven, I would say, because rather than storing changes in the tables for you to pull, this actually publishes the changes directly into your Azure event hubs in real time. So this enables a lot of reactive architecture. So instead of like one job running every hour to pick up the changes, you have consumer application processing all the changes, which is pretty good. And then we have Azure functions with SQL trigger bindings. Let's actually bring change tracking into application tier with the Azure function triggers. So how this exactly works is an Azure function with a SQL trigger binding watches specific database table. So under the hood, it uses change tracking when rows are inserted, updated, or deleted. The binding fires your function with a list of change rows. So your function receives the read-only list or the change objects, where each object has a change type property like insert, update, delete, with a full row of data. So this triggers all the polling, the checkpoints, the retry logic, and everything for you. And then the setting up is just one portion of it. It just has mainly three steps, the setting up. Let me quickly tell you from an exam perspective. The first one would be enable the change tracking on both the database and the specific table. Your step two would be to add the Microsoft Azure extension to your app project. And step three would be to decorate your function with a SQL trigger attribute, specifying the table name and the connection setting name. So just remember these. And the last step would be your function runs on row change, processes each change, and then binding automatically according to the change. So just remember these four steps and you're good to go. So in real time, so that's why it matters in the exam perspective and in real life, because new customer records are inserted into a SQL table. SQL trigger fires an Azure function. The function calls the Azure Open API, Open AI to generate this embedding for the new record, and the embedding is written to the vector store. So this is more like a process where it just keeps going. And then the last step would be to enforce mainly the change tracking under the hood. So just keep these four steps in mind and you should be good to go. Okay, so let's bring in together with all the key takeaways from domain two. I'll give you like a mental model for each area. So the first security one for security is that always encryption or encrypted stop privileges insiders from reading data. Like I said, the database never sees plain text, and dynamic data masking hides data from query results, without changing the storage, but it doesn't stop privileged users. Whereas row level security controls which rows are visible, the transparency at database level. Whereas what we spoke for authentication is managed identity beats the stored credentials. So system assigned for a specific resource, user assigned when multiple resources need same identity, and key vault for any secrets that remain. And remember, like we said, the OIDC is for the CI/CD pipelines. And then a mental model for the performance. So for execution plans, always look for scans, key lookups, and thick arrows. Like I said, remember the triangle, look up for that if you find any issues. The query store is more like a historical regression detection, and the DMV we spoke about is real time state. And then there's a column store, and there's partitioning. Like I said, the name mentions it partitions the tables. And then we have the CI/CD mental model, which is more like for deployment, and the DACPAC is for deployment, whereas the BACPAC is for export. And that just covers that. And then for change tracking, the CT, which is a lightweight primary type, gives you the full before and after values, reads from the transaction logs, and that covers everything we spoke about in the previous slide. So, yeah, with that, that's the complete tour of our DP-800. And in 45 minutes, we were able to cover security, performance, CI/CD for database, and tracking patterns. I would love to explain more, but we're running out of time, so I don't want to keep you guys waiting. But yeah, like Philippa said, thank you so much for this opportunity. And all of us will be given exam vouchers. So please make good use of it. And I really hope it's helpful for you. Everything covered today will also be shared in the chat. So you can also go through the slides. I'll also be sending you some exam resources. So, yeah, with that, we come to the end of the session. Thank you so much for this opportunity, Philippa. Are you there?
I am here, and thank you so much. That was excellent. So yes, everybody, let's join us for session 3, and I'll be including the form now because I know everybody's having lots of questions about the vouchers. I'll just give a compliance rundown as I send that out.
Mhm.
And excited, yeah, no, this is such a fantastic. I'm excited for the next session. We'll
Thank
see
you
you all
so
there.
much.
Thank you, appreciate it. Great job.
Thank you. Bye. See you guys there.
ஆ ஃபர்ஸ்ட் அது பண்ணு. இல்ல அது மாரி இல்ல. ஃபர்ஸ்ட் இது மாரி பண்ணணும். இது மாரி பண்ணணும். கரெக்ட்டா பண்ணணும். கரெக்ட்டா பண்ணணும்.